Hi class, greeting to friends and Padai. In this video, I will do a get valve simulation with CFDSOF. My name is Daffari Putri Utami and I'm doing this to complete my assignment for numerical method class. So first of all, we should know what is CFDSOF. So CFDSOF is the first CFD software developed from Indonesia, and it covers the majority of fluid problems such as simple flow, heat transfer, multi-phase, and so on. So we're going to using this CFDSOF to help us in this gate simulation. Here are the tutorials for the gate valve simulations. First of all, we should set the surface refinement to maximum level 2 in geometry mesh. And then we have to set the dimension for box mesh. I'm using the auto size dimensions. And then we set boundaries for the gate. In X minus, we set it as inlet, and in X positive, we set as outlet, and in Y negative, we set it as boundary, and Y positive as wall. And then after that, we have to generate the mesh. Before that, we have to pick mesh location in X, Y, and Z. We're going to click the location icon to locate the mesh. We have to make sure that the mesh is inside the gate so we can generate it perfectly. And after that, we generate the mesh, and here are the picture of the results of the generating of the mesh generation. And then after that, we have to do the simulation setup. First, we set the simulation model, and for the time we're using steady state, and we have to make sure that the flow is turbulence with bronze model. And this is a single phase. And because this is the turbulence model, we have to set the turbulence model. We set it in the simulation to SSTK omega. And then since we're using air in the simulation, we have to check the fluid properties to make sure that the properties is correct, the density, dynamic viscosity, and etc. And then after we setting up the simulation, we set the boundaries conditions as mentioned in the previous. So we have to make sure the boundaries is correct so the simulation could go perfectly. And then in the simulation, I'm using 2.2 meter per second velocity with iteration 3000. And then after that, after doing the simulation, we will get the graph, and here are the graphs. The first graph is momentum residuals by time, and the second graph is turbulent residuals by time. And turns out that the iteration stopped not long after the 1000 iterations. And then after doing the simulations in CFD software, we're continuing the calculation for pressure drop and debit in ParaView. And we're inputting the formulas and until we get the pressure drop and debit in each of the inlet and outlet. And here are also the picture of the inlet and outlet. And these are the graphs for the inlet and outlet as well. And these are the results for the inlet, outlet, and areas. And for the areas of the circle, we got 0.0021. And then after we're getting these results, we have to manually input them, manually calculating them. And I'm using Excel as help. And after getting the results by previous simulation, we're calculating the pressure drop and debit. And turns out the results for the pressure drop is 0.0037 Pascal, and for the debit is 0.000475 meter cube per second. And that's all my simulations. And last but not least, I'm taking this quote from Terence McKenna that you are an explorer and you represent our species, and the greatest good you can do is to bring back new ideas because our world is injured by the absence of good ideas. Our world is in crisis because of the absence of consciousness. So to make good ideas, stay conscious. And that's all my presentation. Thank you very much.